Welcome everybody, Sheldon here with Data Systems Architecture, and this is the first video in our series, Advanced Concepts and Techniques for ClickHouse. The first thing I want to discuss are gotchas, deal breakers, challenges, just reasons in general why you would avoid ClickHouse for your data warehousing project or for your data systems project. And let's start off by discussing data consistency, because data is eventually consistent in ClickHouse, which means on a multi-node cluster, any replicas between your data can become out of sync. And there are ways to manage this, but they require operational excellence and a lot of diligence on the ingest side. And in general, you can't really rely on ClickHouse on always having exactly the same data on every replica in your node. And what this means is that when you run a query, the query engine is going to direct that query to one of the nodes on the cluster that has a replica of the data you need, and it may return a different result from one node to another on the cluster, and that can be a big problem. Second thing is, if you are used to relying on upserts or update statements in your ingest pipelines, then you need to rethink that completely when you're using ClickHouse. There are special table engines that you can use to support these upserts and update operations. However, it's going to cause even worse data consistency problems. It will also require, again, a lot more operational excellence and diligence on the operations and data integrity checking, as well as more sophisticated pipeline code and more sophisticated query code. And there is a video in this series discussing these techniques in more detail. Null values are also not well supported by ClickHouse. And so if you are used to working with null values and you're going to import null values from another system, you need to consider representing those some other way in your data set, because they do not scale up well, and they will screw up your queries are not going to match if you migrate null values from one system into ClickHouse. There are special functions and there are things you can do with this, but in general, be very wary of using null values in ClickHouse. Relational data is not well represented in ClickHouse. It is not a relational database, and so if you're used to using relational databases, then you need to start thinking more about how you can actually duplicate your data to get all of the data you need for your join statements into single tables, because this will be much more effective at query time in terms of optimizing the amount of memory and compute time that it takes to return your query. Join statements are supported in ClickHouse and well supported. They are very nice. They work very well. However, when you start joining across a lot of tables, due to the size of the tables in a system like this, they can become very memory intensive, and then the query results, of course, will take more time. And so it's important that you start planning changing your relational model to a flatter model through denormalization, which there's another video in this series about denormalization in particular, and plan that as part of your project. The next thing is these magical ingress tools, as I call them. So if you're used to working with a third-party vendor or some kind of software as a service or open source thing like Debezium to ingest data into your database, you're probably going to be disappointed when you try using that with ClickHouse. And of course, some of these work to varying degrees, but because the performance optimizations in ClickHouse require you to have a very well thought out strategy for your schema design and for choosing the kind of compression for your columns and your replication strategy. You can't really rely on automatically mapping field types from one database to another with one of these automatic tools and expect it to work well. Because the schema is just not going to be right. And I've also run into scaling issues with these systems when I've tried to use them. And I really think that you ought to just plan on writing custom data pipeline code for ingress into ClickHouse as well as for your initial migration. So the last thing I want to discuss is ingress latency. And one of the drawbacks of ClickHouse, one of the trade-offs, is that ClickHouse is a read-optimized database, and the way that functions under the hood is as you add data to a table, the existing data on disk can be reorganized. And that data is reorganized on disk, so when you go to read, the data is in the proper order from your order by statement in your table declaration syntax, and this will allow the reads to happen much more quickly when you're using those fields and filtering by those fields. However, it will cause a lot of thrash every time you add new records to those tables. And so the general rule of thumb is to have no more than one write operation per second across your entire cluster in ClickHouse. And so you have to design your pipelines to use batch inserts to add multiple records in a batch at a relatively low frequency. And this can still give you high throughput, but you're going to have relatively lower latency than, say, a dedicated time series database where you can just stream in one row at a time and it works really well. ClickHouse is not the right database if you are working with latency intensive applications. And with that, I think that if you want more detail about these problems, go through the other videos in the series to see some of the techniques for working around this. And I want to mention that I love ClickHouse. And if you're considering using ClickHouse and some of these issues are worrying to you, I think that you should watch the rest of the videos and see if you can find a way to work with them and make it work, because it's really, really good technology for large-scale aggregate queries. And I'll see you in the next video.